Okay, you guys, this is very exciting. We are on chapter 10. And chapter 10, you guys, combines chapter 8 and chapter 9. So all the stuff that we're going to talk about here today is stuff that you have already learned, except there's one small difference, and it's actually an enormous difference. We have two proportions now instead of just one. Do you remember in chapter 8 we did a one prop z int? Well, let's read through this question because it's kind of interesting. We have this Gallup poll done, and we surveyed 800 randomly selected people in 2001. And we also did 811 people in 2021. And we are comparing the two proportions. It's interesting because I'm sure a lot of you can relate to this. People aren't going to the movies as much. You can see a lot of movie theaters are closing. And we are comparing adults in 2001, which is when I was in high school. We went to movies basically every weekend. Versus in 2021, I feel like you people don't go to the movies that often. So interesting, we have a P hat from 2001, which notice my little acronym, my subscript here, P hat from 01, versus I have a P hat from 21 over here. And look how different those two numbers are. 66% of people had been to the movie theater at least once that year in 2001, versus only 39% have said, yeah, I saw a movie in the last year. That seems like a significant difference. And so what are we supposed to do here? The directions say calculate a 95% confidence interval for the difference. This title of this chapter is difference in proportions, or later we're going to get into means. And they're also telling me the direction of the subtraction, which is really important. 2021 minus 2001. Okay? When we are subtracting, sometimes we get negative numbers, sometimes we get positive numbers. The direction needs to be obvious. So it needs to be either stated in the question, or if you get to decide, you have to state which direction you're subtracting, okay? Let's start by defining some stuff. So right now I have two different p hats, and yes, these are p hats. They're not p's. They're not understood numbers about the entire population. These are just based on two samples. One of them's 800, one of them's 811. And by the way, the sample sizes don't have to be the same. Sometimes in stats we can't have the same sample size for every single sample we take, and we try to, but it's not a big deal if it's not, okay? I'll show you how those sample sizes actually impact our numbers when we get into the formulas and stuff. So anyways, we are doing a two prop z int, and it's a z interval because z always goes with proportions, if you remember that from chapter 8 and chapter 9. See, it's so cumulative and beautiful, you guys. Let's define some stuff. Excuse me. I am defining my P from 01 as the population of adults in 2001 who saw at least one movie, is what the wording of the question says, in the previous year. And that population where the sample was taken in 2001 was from U.S. adults, okay? And I'm going to define, it's literally a copy paste, but I'm doing a P from 2021, and my acronym, or my little subscript is 21 there for 21. And the population is almost the exact same, but it's from 2021, okay? And what button in the calculator are we going to be referencing? We're not ready for the calculator yet, so hold your horses, but we are trying to estimate a difference. It's asking, that's the entire purpose of an interval. We are not testing a claim here. We're not doing a ho and a ha. We are constructing an interval, which is different. We are trying to estimate the difference. And we do have two proportions, duh. I have two numbers circled in red up there. Therefore, when I'm ready for the calculator, I'm going to do a two prop z int. And the question said, please be 95% confident, so that is why that number is there. Here's how our conditions are going to be different, okay? Do we have a random sample? Yes, in fact, we have two of them, so you need to talk about both of them when you check the random sample condition, okay? These conditions are the same, but there's more of them, or more stuff to write because we are taking two samples, okay? We have two different random samples. We have 800 U.S. adults from 2001, and we have 811 U.S. adults from 2021, okay? Yeah, it's annoying, you guys. We have a lot of writing, but hey, this is simple. These are easy points, easy buckets, easy money, okay? Independent conditions. Since we took random samples, we need to make sure our sample's not too big. Do you think there's more than 8,000 adults in 2001 in the entire population? Duh. Also, do you think there's more than 8110 adults in the population in 2021? Duh. Okay, so the 10% condition is fine for both of them. But yeah, since we took two samples, you have to write two different things. Okay, but it's the exact same thing that we've been writing in chapter 10 and in chapter 11, okay? So don't come at me. All right, normal condition. What are you supposed to do for proportions for normal condition? Think for a second, maybe pause the video and whisper to somebody around you, your brother, your sister, your dog, your cat, whatever. For proportions, we do NP and N1 minus P, but I have an N and a P here, and I have a different N and a different P here. Yeah, we got to use both of them, okay? Remember, NP and N1 minus P, but this is going to look like a lot. Nobody panic. Make sure that you're using a P hat, okay? Because the only two numbers we're given here, these two numbers, they are both P hats, my friends. They are from samples. So we have to be very specific and intentional when we are using symbols, okay? Those numbers are P hats, and they're the only numbers that I have. And so I'm taking the N from 2001 times the P hat from 2001, and that gives me this, which is definitely bigger than 10. I got to check all four of them. What about the N from 2001 times 1 minus the P hat from 2001? We got to check all of those, and then I'm going to repeat the process for 2021. All of these numbers are bigger than or equal to 10. That is what we are looking for. That tells me, you guys, this part is important, the sampling distribution of P hat 2021 minus P hat 2001. I'm subtracting in the direction that the question is telling me to do. The sampling distribution of all of the differences is approximately normal. Okay, I'm still not ready for the calculator yet, but we have finally written out all the stuff, and I've left myself like very little room. Do you remember this formula from the formula sheet? It's in words on the formula sheet, and I am going to use the statistic. What would the statistic be? I am interested in the difference in proportions, and I have two different P hats, and I'm told which direction to subtract them. That means I'm doing the P hat from 2021 minus the P hat from 2001. That is going to be my statistic. It's the difference between these two P hats. Okay, so the other thing I'm going to do you remember the critical value for a 95% confidence interval for proportions? It's always 1.95. Remember, you could do inverse norm, 2.5% on each tail, comma 0, comma 1, but it's 1.96. I think I misspoke, 1.96. And then let's talk about the standard error of the statistic. I wrote standard deviation. I guess on the formula sheet it says standard error, so let me change that. My bad. Let's go to the formula sheet real quick. Forgive me for flipping back and forth, but there's a section that we've been skipping. Here we are, proportions. These are the ones that we used last chapter when we were doing intervals and tests, the last two chapters. But look, when we have two populations, 2021 and 2001, we are going to use this thing. We have two different P hats, okay, with a bunch of different N's and P hats and whatever. It's on the formula sheet in the two population category for proportions. Okay, so I'm going to use this, and you know what your P hat 1 and your N1 is, and the P hat 2 and the N2, that's 2021 and 2001, okay? So yeah, it looks kind of crazy, but let me show you what it looks like when I plug in all my numbers. So let me recap real quickly. The statistic was the difference of the two P hats that we had. And I am following the directions that they told me to do 2021 minus 2011. This is the 2021 P hat. This is the 2001 P hat, okay? 1.96, once again, how do you find that? That's our critical value, and it's always 1.96 for a 95% confidence interval for proportions. But if you want to or need to look this number up, remember it's inverse norm, and we have 0.025 on each tail, comma 0, comma 1. Remember, that'll give you negative 1.96 in the calculator, but we got a plus or minus, so nobody cares about the negative. Anyways, here is what I was talking about on the formula sheet. So my N1 and my P hat 1 are the first thing that I'm subtracting from 2021. So the 39% times 61, that's the N from 2021. Now I'm repeating with all the numbers from 2001. Those go here. I could type this whole shebang into the home screen, but that's kind of a lot. So I could, but maybe it would be easier to, while you're looking at your calculator, reference the 2prop_z int. What you're going to have to do is go under the interval menu. Don't choose the one that says test. We're not ready for that yet, you guys. 2prop_z int. And it asks you for a bunch of stuff. The X1 means the number of people in 2021, the beginning of the subtraction, that said, yes, I went to a movie and it's the whole number of people. So it's actually the n times 21 times p hat of 21. So that was the sample size times this proportion said, yes, I went to a movie in the last year. Like mathematically, how do we figure that number out? It's this number. Your calculator will not like it if you put a decimal there because it's asking for a whole number of people. We were only given proportions in the problem, so we need to know how many people in the sample said, yes, I went to a movie. How do you find that? It's in your conditions. It's the sample size times the proportion that said, yes, I went to a movie. That tells us that 316 people in 2021 said, yes, I went to a movie in the last year. Okay, our sample size is 811. How do we find the number of people in 2001 that went to a movie? So you take your sample size, which is 800, and you multiply by the proportion that we were given for 2001, which was 66. That tells me that 528 people in that sample said, yes, I went to a movie in 2001. And the sample size was 800, and the confidence level, make sure you put that as a decimal. Those are the 5 things that the calculator asked you for, and it should spit this thing out, you guys. Okay, that means, do you remember how to write your conclusion? We are blank % confident, blah, 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 blah. How do we write that? Here we go. We are 95% confident that the true difference in proportions, and I am repeating the direction of the subtraction so that it's very clear, of U.S. adults who went to a movie in the previous year is between this number, this proportion, and this proportion. Hey, the entire difference is negative. Okay, when we subtract 2021 minus 2001, we are estimating that the difference will be somewhere between these two numbers. This entire interval is negative. That tells us, read what I have in red here. People aren't going to the movies as much. Our interval was conclusive. 0 is not in here. That means that I don't think that there is no difference, if you can understand that. That means I am estimating that the difference is negative. And when I subtract in this direction, that means that people went to the movies a lot more in 2001 than they did in 2021. Mic drop, end of story. Okay? That is, in a nutshell, how to do a 2-prop z int. And what you are going to do is you're going to explain this problem like I do teaching in class. You are going to teach your group members tomorrow how to do this problem. And then all 4 of you are going to attack this one together. And then I will come around and I will check it and make sure you understand everything and answer whatever questions that you have. So please let me know if you have any questions over this. Hopefully that's pretty self-explanatory. Thank you for watching, and I can't wait to hear you teach your friends tomorrow. Have a great night.